Hi, I'm Doug Broad, your instructor for EGR 250 Statics and Strengths of Materials. In this video, we're calculating reactions, and this is a demonstration of problem 2-36 in the text. So here's the problem as it's stated in the book. A bridge over a river is loaded at 3 panel points. Determine the support reactions at A and B. Well, what are panel points? Well, those are the connecting points between the web members and the cord members. And they're the locations, the only locations that should be loaded on a truss to prevent problems with bending forces being induced. But this problem is much simpler than it appears. Do we need to know all these things about a truss? First, start by asking questions. What are you asked to solve for? Well, determine the support reactions at A and B. What loads and dimensions are given? Well, I see 3 loads, 2 kips, 3 kips, and 4 kips. How about the dimensions? Well, I see horizontal dimensions and I see vertical dimensions. All the loads are vertical, so the horizontal dimensions are probably important. What about the vertical dimensions? Are they also important? Is the shape of the truss important? What are the reaction capabilities? On the left, I've got a pin. On the right, I've got a roller. What do we know about pins? What do we know about rollers? This will help you translate the space diagram into a free body diagram. Can any of the reactions be solved by observation instead of by calculation? Well, that gets back to knowing what components are available at each support. So the process. Draw a free body diagram. In case you are solving for a system, in this case you're solving for a system of forces. The details of the truss itself are unimportant, so don't get hung up on the shape, or don't spend lots of time drawing the exact shape of the truss or copying down all the dimensions. Figure out what's important and draw that. After drawing the free body diagram, which equations can be solved for by unknowns? Directly start there. So here's a possible space diagram. Notice it's just a simple beam, and there are loads on that beam. All the loads are applied on a common level, so we don't need to illustrate any different levels. The pin has now been converted into 2 loads, or 2 component reactions, AX and AY. And the roller on the right is only capable of resisting loads perpendicular to the surface on which it acts. So it's going to be vertical. By observation, I have 3 vertical loads. Since there's no horizontal load, there can't be any horizontal reaction, so A sub x has got to be 0. That doesn't require any calculation, but does require inspection. By moments, I can choose to take moments about A or B to solve for the reaction that's not at that point. So let's solve for the reaction at B by taking moments about A. So here's our equation. Sum of the moments at A, all the distances need to be measured from point A, have got to equal 0. So that equation, that rotational equilibrium equation, starts with the distance of 80 between points A and B times the unknown at B, that's counterclockwise, minus 2 times 20, that's 2 kips times 20 feet, minus 3 kips times 40 feet, minus 4 kips times 60 feet. So summing that, simplifying it, we've got 80B on one side equals a sum of numbers on the other side. Now, each of those terms is the product of a force times a perpendicular distance. So the resulting unit should be 400 kips times feet. Simplifying that gives you B is equal to 5 kips. Okay, so we're going to continue. From the previous slide, we know a few things. We're missing what AY is, so let's solve that by vertical equilibrium. Sum of the forces in the y direction equals 0, so look at only the vertical forces. should I put AX in there? No. AY plus B minus 2 kips minus 3 kips minus 4 kips should equal 0. Simplifying, AY is equal to 2 plus 3 plus 4 minus 5. Where did the 5 come from? It's the substitution for the value of B. That equals 4 kips. So next I need to do a check about taking moments about B to make sure that AY is still 4 kips. Sum of the moments about B equals 0, so 4 kips times 20 feet plus 3 kips times 40 feet plus 2 kips times 60 feet minus 80 feet times the unknown component AY equals 0. So 80 AY is equal to 80 plus 120 plus 120, or 320 kip feet. So AY is equal to 320 kip feet divided by 80 feet, or 4 kips. That's our check. And now that we've checked it, we're sure that the values are right. The only unchecked value is the A sub x.